Now we jump to the mineral horizons. The most important one, or the most widely discussed one, is the A horizon. A horizons are surface horizons, mineral horizons with some organic matter, humus accumulation. It's very important here that when we are talking about the humus, that means that this organic matter has been decomposed. So it's not a raw organic matter like in an H or O horizons. So this is decomposed. The most important property of these horizons that they are much darker than the underlying horizons, and they have usually smaller clay content than the underlying horizons. You can see two A horizon examples. On the left side, you can see a grassland soil. On the right side, you can see forest soil. The depth and the organic matter content of these A horizons are basically determined by the vegetation that influence the soil formation. Usually, grassland vegetation produce much deeper organic matter-rich A horizons, while in a forested area, the organic matter-rich topsoil A horizons are much, much shallower. E horizons. E horizons are near-surface mineral horizons, but unlike the A horizons, they are not defined by organic matter content. Instead, they are defined by loss, material loss. As you can see, for example, this is an example of an E horizon, and a very extreme example of an E horizon that you can see on the right side of the slide. It is a pale, grayish, colorless horizon because materials have been removed from it. For example, clays, iron, aluminium, or even the combination of these materials. Because of this loss, the E horizons are usually lighter in color than the horizons above and the horizon below. In the field, they are often appear pale, bleached, or ash-like gray. This lighter color is one of the strongest visual clues because this is what differentiates. This is what is the most vivid signs of having an E horizon in a soil. This is so-called, the E horizons are so-called elevation horizons. Elevation means washing out, because the water moving downward through the soil profile and the Liberia, as we discussed last time, the amount of rainfall exceeds the amount of the water leaving the soil through evaporation. That is why water moving downward in the soil profile, it removes fine particles, certain substances, leaving behind a lighter, more depleted layer. It's very important to mention that not every pale horizon is automatically an E horizon. We must always consider its position in the soil profile, the contrast with the adjacent horizons. For example, if we see much darker or much colorful horizon below these ash-like grayish horizons, that means that most probably this is an alluvial E horizon. B horizons. We have two types of B horizons in the soil. B horizons are subsoil horizons. The B horizons form below E, O, or H horizons, and they are characterized by the evidence that pathogenic processes have acted stronger in the subsoil. The evidence may take different forms. It may be an accumulation of clay, iron, aluminium, organic matter, and other substances. And these are so-called alluvial accumulation, B horizons. For example, if clay has moved downward in the soil profile and clay has accumulated in the subsoil, we have a so-called BT horizon. If iron or aluminium have accumulated in the subsoil, we may have a BS horizon. We are going to see it later. It is also important to understand that not every B horizon is the same. Some B horizons are clearly alluvial, that you can see on the left side of the screen, in which clay has accumulated in the subsoil, and others are more transitional, that you can see on the right side of the screen. That means that they show structure, color, without the evidence of any kind of accumulation here. So as you can see on the right side of the screen, in this kind of B horizons, where we see the gradual transition between the organic matter-rich topsoil into the organic poor parent material, this transition is the so-called transitional B horizon. C horizons. C horizons are parent materials. C horizon is basically the soft parent material. It is unconsolidated, for example, loose sediment or just partially consolidated. In the field, the C horizons often look less structured, biologically less active, and less structured, organized than the horizons above it. So basically, the C horizon is the soft parent material, which can be, for example, loose sand or, for example, a clay material. In contrast, the R layers, they denote the hard bedrock underlying the soil. It is different from the C horizons because C horizons are unconsolidated or just weakly altered material, while the R layers are continuous hard rocks. In practical field terms, the key feature is penetration resistance. An R horizon cannot be cut with a spade. For example, limestone, granite, sandstone. Roots may enter only into the cracks or fractures, but the material itself remains a hard rock rather than the phylogenetically altered soil material. It's very important to take into consideration the hard parent material, the hard bedrock when we do field soil investigation, because the presence of the hard bedrock and the depth of it from the surface tells us something about the depth of the soil, rooting depth, drainage, and in general about the space that is available for the soil development. So in simple terms, the R layer is where the soil ends and the hard bedrock begins. The slide explains, so these were the master horizons. So A, E, B, C, and R. So these are the master horizons, and sometimes it is necessary to combine these letters. This slide explains the so-called transitional horizons, and this is one of the topics that can cause confusion in the field. The transitional horizon is a horizon that shows characteristics of two master horizons. For example, a transitional horizon called AB shows the characteristics of an A horizon and the B horizon. That is why we call it as an AB. The first case, as you can see, when we have two cases of transitional horizons. For example, on the left side, you can see transitional horizons with properties of two horizons superimposed. And on the right side, you can see transitional horizons with two horizon properties separated from each other. Let us see what I'm trying to say here. For example, when we say AB horizon, that means that we have a transitional, continuous, gradual transition from the A to the B horizon. When we have a BC horizon, that means we have a transitional, gradual transition from the B into the C horizon. This is when we have superimposed horizons, transitional horizons. The other scenario, when we have separated properties, when distinct parts are recognizable in one horizon. This is marked with a slash between two master horizon letters. What does this mean? When we see in the soil horizon, in which we can see a chunk of a dark organic matter rich material which comes from the A horizon, together with more yellowish, more pale horizon, which comes from, in this case, from the C horizon. So they are distinct in one horizon. So you can see distinct parts of both of them. We put a slash between the A and the C because it consists of materials from the A horizon, consists materials from the C horizon, but they are not, we don't see gradual transition between the two. We see separate parts of the two horizons in one horizon. Usually this is caused by plowing in the soil when the topsoil and the subsoil is physically mixed with each other.